4.2. 4.2, I suggest you go ahead and look on your blackboard under handouts, print off the trig identities, print off the chart for your trig values, and print off your unit circle. You'll need all of them for 4.2, 4.3, and chapter 7. Go ahead and get them printed off now, and you're going to need at least 2 of them for chapter 4. So go ahead and have them, that way when I refer to them, you know what I'm talking about, because I doubt y'all can read this from here. All right, so 4.2 is rotation of axis. What's going to happen here is we're going to take a graph, and we're going to take the entire coordinate plane and rotate it however many degrees it tells us to. Okay? So on page 147, which is where 4.2 starts, it gives a kind of cryptic picture. So what this picture does is it has an x-axis and a y-axis, x horizontal, y vertical, and it has a line that goes through them about right there. Okay? And it tells you there's a vertical line right here, and that is M, that is R, and that distance is the value Y until we get to P, is what it tells us. Then it's going to take the entire axis, the entire picture, and tilt it so many degrees. So your new graph, your y-axis now goes that way instead of being straight vertical. Your x-axis now goes this way instead of being straight horizontal, which means the line that goes through it is also at a different angle. So you've got to be very careful on it. Your distance right here is now become the other distance for y prime, and I drew my line off more so than they did, so it doesn't look quite right. But you can see more so what's going on when you realize that the entire graph has just been kind of turned sideways a little bit, just been tilted about, looks probably about 15 degrees. They do a lot of math there. They've got all the numbers, the distances from ON minus the distance from MN equals ON minus RS. A lot of equivalencies. What they're doing there is they're starting off doing the trig for you. They're telling you that the x change, the x value, is going to be x prime cosine theta minus y prime sine theta. They're doing the trig for you. These are where the formulas on the next page, the rotation formulas on page 148, are coming from. So that's what we're going to focus on. You have your rotation formulas, x equals x prime cosine of theta minus y prime sine of theta, and y equals x prime sine of theta plus y prime cosine of theta. Make sure the x is minus, the y is prime. So that's your rotation formulas. Again, you have to have these memorized as well. So all the formulas I've already given you, plus these, and your trig identities, and your trig chart, and eventually your unit circle. All will get memorized. So what we're going to do, example 1, transform the equation x squared minus y squared minus 9. Actually, I'm going to do that down here so I have more room. X squared minus y squared minus 9 equals 0. And they want you to transform that equation by rotating the axis by 45 degrees. Okay? So what we're going to do is with theta equals 45, we're going to take these sine and cosine functions. So we know that theta equals 45 because they told us that in the question. So we're going to say x equals x prime cosine of 45 minus y prime sine of 45. Okay? To get those values, we're gonna look at the chart, the square one, that has all your degrees and your sines. It's the sine of 45. So if we're gonna move at 45 degrees, you want, the first one is cosine. Cosine of 45 degrees is 1 over the square root of 2. So we're gonna get x prime over the square root of 2. Minus, you want sine of 45 for the y. Sine of 45 is the same thing, 1 over square root of 2. So y prime over the square root of 2. All right. What the book has now done, because this is not the formula they have. Their formula, actually yes it is, I'm sorry. I apologize. That is the formula they have. I took a more complicated route to do it when I did this on my own. So this is the formula they get for x. We need to do the same thing for y. So y equals x prime sine of theta. Sine of 45 is your 1 over root 2. So x prime over root 2. Plus for your y should be a plus. Y prime times cosine of 45, same thing. Cosine of 45 is 1 over the square root of 2. So y prime over the square root of 2. Should be the equations they came out with in the middle of page 148. All right? So that's just what x and y is. We haven't done anything to the original equation. All we've messed with so far are the rotation formulas. So we're going to take our equation, x squared minus y squared minus 9 equals 0, and we're going to substitute x and y in for these new values. These are the values after it's been rotated. So this is before rotation. We need to make it into after rotation. So x is x prime over square root of 2 minus y prime over the square root of 2 squared because it's squared in our original, minus because our original problem was minus our y value, x prime over the square root of 2 plus on the y prime over the square root of 2 again, squared minus 9 equals 0. Go through, square everything. So you're going to expand and FOIL this. It's going to square the first term. That's going to be x prime squared over top of 2 minus 2x prime y prime over 2. So those will cancel, leaving you just x prime y prime. Plus, and you squared the last one, y prime squared over, make sure you tell the difference in your primes and your ones, 2. Okay, that's just the first set of parentheses squared. You can take your time, write it twice, FOIL it out, make sure it comes out to the same thing I got. I'm writing crooked here. Minus, because this is minus, you still need to distribute that minus into everything that you're going to FOIL. You've got to FOIL before you distribute. You cannot do it the other way around. You've got to multiply before you do, or exponents before multiplication. So we still need to FOIL this out before we distribute the negative. So keep a set of parentheses. FOILing out, you get x prime squared over 2 plus x prime y prime, as we saw before, to be over 2 divided by 2, which will cancel. And then you'll have plus y prime squared over 2 minus 9 is 0. Still need to distribute your negatives, so that's why we still have the parentheses left there. X prime over 2, x prime is being squared, minus x prime y prime, plus y prime over 2 squared on the y prime only, minus, because that gets multiplied, x prime squared over 2, minus x prime y prime minus y prime squared over 2 minus 9 equals 0. Slowly getting longer, right? What we're going to do now is we're going to combine like terms. We have a minus xy and a minus xy that can be combined. X prime squared and x prime squared, y prime squared and a y prime squared. You can combine your like terms to make it as simple as possible. So x prime squared over 2 minus x prime squared over 2. Those cancel each other out. Y prime squared over 2 minus y prime squared over 2. Those cancel each other out. Okay, one positive, one minus. Negative x prime y prime minus x prime y prime gives us a negative 2 x prime y prime minus 9 equals 0. Now again, they don't like having the negatives up front if we can avoid it. So go and divide everything by negative 1, gives you 2x prime y prime plus 9 equals 0. And that's your equation. Take your rotation formulas, make sure you use the correct theta, use your chart for whatever theta it's telling you, 45 degrees, you look at the 45 one, and then you take it and you plug the new rotation formulas into the original equation they gave you, square, simplify, combine, whatever's left over, make it look pretty. Get rid of the negatives up front, try to avoid the fractions, get rid of fractions if you have them. Eliminate what can be eliminated, and it came out nice and pretty for us. Okay? And then they draw a picture. You can see both axes in their picture. What I want to explain, because they don't really explain this, and then you look at your answers for 4.3 and everything's kind of all over the place. So what they have here is they have your original graph. That's your x and that's your y. And then they say, since it's been rotated 45 degrees, our x and our y are not where they should be. So they take it and they say we have x prime, y prime. So the purple is our graph now. And then you're going to take that graph, and that is where the graph is actually done. On your y primes. Okay. 4.3, we'll do it backwards and keep our primes straight and even like we're used to seeing it, and do a rotation after the fact. All right, so for the next example, example 2, find the acute angle of rotation such that the transformed equation of 2x squared plus root 3xy plus y squared equals 8 will have no x prime y prime term. So we want the angle that will eliminate the x prime y prime term. What we're going to do is we're going to start off the exact same way. Once we get our long equation with everything already plugged in, with our rotation formulas, and make sure everything's simplified, we're going to take everything that's x prime, y prime, and set it equal to 0 because we want it to go away. So that's how we're going to eliminate that and find which theta value would allow that to happen. So our equation, 2x squared plus the square root of 3 xy plus y squared equals 8. And there's a lot of work to simplifying it before you can just get the x and y out of it. So what we're going to do is we have no idea what the angle of rotation is. Our job is to figure that out. So we're going to use the rotation formulas as they are. You're plugging in the x prime cosine of theta minus y prime sine of theta for x. And you're plugging in the x prime sine of theta plus y prime cosine of theta for y. So everywhere there's an x, you're going to plug in your rotation formula. So we have 2 times, you have your x, so that's x prime cosine minus y prime sine. Squared. So I I've made it to the end of 2x squared so far, plus the square root of 3. Then I have x times y, so I have my x again. That's your x prime cosine of theta minus y prime sine of theta times your y, because I'm still up here. Y is x prime sine plus y prime cosine of theta plus y squared squared equals 8. So this kind of took up the entire board all of a sudden. Went from nice and only a third of the board to the entire board. What we gotta do is we gotta simplify this out. So I'm gonna write a little bit smaller so I don't run out of room. So we have 2 times squaring this one. We square the first, multiply them together times 2, square the last, or expand and FOIL. So we're gonna get x prime squared cosine squared of theta. So that's the first one squared. Minus 2x prime y prime sine of theta cosine of theta. Plus y prime sine, or y prime squared sine squared of theta. Be very careful here. It's real easy to miss a square, or to miss theta, or to miss an x, or miss a y. Make sure you're not missing anything. Plus square root of 3 times, and we're multiplying these together, so we're FOILing here. X prime cosine times x prime sine. X prime squared of sine theta cosine of theta. First times last gives me plus x prime y prime cosine squared of theta. Inside minus x prime y prime sine squared of theta. Minus, that was this one. So last times last, y prime squared sine of theta cosine of theta. Okay. Close my parentheses because all that's still multiplied by the root 3. Plus, for this one, I'm going to go and continue it on down here, but know that that is a continuation. We're squaring this one, so that is x prime squared sine squared of theta plus 2x prime y prime sine of theta cosine of theta plus y prime squared cosine squared of theta equals 8. We're still not done simplifying. We've got to distribute the 2, we've got to distribute the root 3. Then we can start organizing and getting things down to a more condensed format. We're not ready to condense it down quite yet. Get rid of all your parentheses, combine line terms first. So we need to distribute the 2. So that's going to give us 2x prime squared cosine squared of theta. Make sure your squares are visible and readable. Make sure you don't accidentally forget to write one down. Minus, we've done the first one, so 2 times negative 2 is 4. X prime, y prime, sine of theta, cosine of theta. Once to each term. To the next term, plus 2 y prime squared sine squared of theta. If you lose one square or you add in another, mess your squares up. Plus, we need to distribute the root 3. So we will have square root of 3 x prime squared sine of theta cosine of theta plus distributing the root 3 x prime y prime cosine squared of theta minus square root of 3 x prime y prime sine squared of theta. Okay. Keep on going. Minus, starting back over here. Make sure you know that minus sign at the end goes with this one over here. Square root of 3 y prime squared sine of theta cosine of theta. Okay, so that's the end of our distributing this. But we're not done with the equation yet. We haven't hit our equals yet 8. It went plus and over to here. So we've got to recopy that down as well. So plus x prime squared sine squared of theta plus 2x prime y prime sine theta cosine of theta plus y prime squared cosine squared of theta equals 8. And what may actually help out a little bit, I don't really like leaving a negative hanging out here at the end because it's easy to forget about. Make that a positive and move your negative over there. You want to leave some sign over there saying plus or minus something. That way you don't accidentally think, oh, it's finished. That way it tells you I'm not finished, it's going somewhere else, but put the negative with the term, that way you don't forget about it later on. Okay? We are almost ready to start condensing. We have only about 1 or 2 more steps. So what we're going to do next is we're going to focus on getting the things grouped together. So I'm going to focus on the x prime squared because that comes first. So x prime squared. I'm going to write down everything that has an x prime squared in it and factor that x prime squared out. So here, if I take the x prime squared out, I'm left with 2 cosine squared of theta. All right, so I've dealt with that one. Does not have an x prime squared, no x prime squared. This one has an x prime squared, so my x prime squared is on the outside of the parentheses, plus the square root of 3 sine of theta cosine of theta. Plus, or actually, hang on, we gotta find the next one with it. X prime squared. No x prime squared. No x prime squared. No, this one does. It has an x prime squared, so we get plus the x prime's already written out front, so don't write that again. Sine squared of theta. So that one's been dealt with. No x prime, no x prime squared. Those are all your x prime squares. Group together, factor the x prime out so you know exactly what's with it. Okay. Next, I'm going to deal with my x prime y primes, just because that comes next in the problem. The problem I'm running into is I don't really want to start with a negative one. So if I start with a negative, I'm going to have to factor a negative out of every single piece. So I'm going to skip this one and come back to it and start with the positive one. All it's going to do is change that first term and use your commutative property of addition. So we're going to do the x prime y primes, and we're starting off with the positive square root of 3 cosine squared of theta. Again, don't put the x prime y primes because we're writing that outside. Since we got the first one done, now we can do minus, and it won't mess up the rest of our parentheses. So minus 4 sine theta cosine theta if we take the xy out. Okay. And then we're looking for anything else than x prime y prime, which we have this last term over here. Take the x prime, y prime out because it's already written. We have minus square root of 3. Take the x prime, y prime out. 3 sine squared of theta. Okay, so this one's been dealt with. This has a y prime only. This one has an x prime, y prime, so we're going to group it together. Plus 2 sine of theta, cosine of theta, so that one's been dealt with. This one does not have an x prime, y prime, so you're done with all your x prime, y primes, right? Now we go on to the next one. All we have left are the y prime squares. So we're going to do plus to tell you that it keeps going, and start with your y prime. So we have y prime squared times 2 sine of theta nothing else has a y prime squared, minus the square root of 3, this is your next one, sine theta cosine theta, and then lastly for your y prime squares is your cosine squared, plus cosine squared theta equals 8. So we're going to look at that for a second before I erase it to start the second half of the problem. Oh, I didn't mean to erase that. Alright, so what we are going to do is we had that long formula, that last 2 rows was that one piece of that equation. We had a group for the x prime squares, we had a group for the x prime y primes, we had a group for the y prime squared, and then it was all equal to 8. Directions to our equation said find the acute angle of rotation such that the transformed equation will have no x prime, y prime term. So we want the coefficient for the x prime, y prime to be 0. We want it to go away completely. So we're going to set only that x prime, y prime set of parentheses that we had in the middle equal to 0. So you can ignore the y prime squared stuff, you can ignore the x prime squared stuff, and you can ignore the equals 8. All you care about is the x prime, y prime. And you'll see more so about that next time. So our x prime, y prime was negative 2 cosine squared of theta plus square root of 3. And actually I had those in a backwards order, didn't I? I had square root of 3 cosine theta with the square and a cosine, minus 2 sine of theta, cosine of theta, minus square root 3 of sine squared of theta. And we want it equal to 0 to make that entire term go away. I didn't mean to erase it at the bottom. I meant to be able to save that. But oh well. Alright, so what we're going to do now is we need to get the angle of rotation, which means we need to solve for theta. There's quite a few thetas here. We've got 4 thetas. And we've got to figure out how to solve for them. So you're going to use your identity sheet here. Quite a bit. We do not have an identity for all of these. One identity that will cover everything. But if you look down, if I can find it, I believe we have a sine cosine one. Down in the product to sums, you have sine cosines. Sine of a number times cosine of a number equals, that's not the one we want to use. I'm sorry, double angle formula. Sometimes it's hard to read this. Double angle formula is sine of 2u equals 2 sine of u cosine of u. U is the theta, V would be like phi, a different symbol. So we're going to use the double angle formulas. Be very careful. I was close to using the product of sum formula, which actually made it more complicated because it would have given you 1/2 times cosine of theta minus cosine of theta plus theta, which gets really complicated. So the the double angle formula has a 2 sine of a number cosine of a number, which is this piece right here. Double angle formula. It goes to sine of 2u is what it tells you. That piece is equal to sine of 2 theta, which looks a whole lot better than 2 sine of theta cosine of theta. Your negative will still fall down, but 2 is part of your formula, so it is gone with the formula. Now we need to figure out something to do with the cosine squared and the sine squared. So I'm just going to bring it down, so I'm doing one thing at a time. So on your identity sheet again, because we're going to use our identities quite a bit, just below your first formula that we just used, the double angle, it says that cosine of 2u equals cosine squared of u minus sine squared of u. So we need to get those together and be able to factor out the square root of 3 so that we have a cosine of a number minus sine of the same number. So I'm going to put those together. Square root of 3, square root of 3 cosine, minus square root of 3 sine squared of theta. Then this piece will fall down, sine of 2 theta equals 0. These you can factor out your square root of 3, leaving you cosine squared of theta minus sine squared of theta minus your sine of 2 theta. Okay. Cosine 2 theta minus sine 2 theta is your double angle formula. That takes it to, you have 2 options. You could do cosine of 2 theta square root of 3 would still be out here. Or we could have gone down and done 1 minus 2 sine of squared of theta. However, since this one's not squared and it's not theta, I'm going to try to keep them to where they're similar. I want this one not to be squared, and I want it to have a similar inside so that I can still do more things with it. So sine of 2 theta equals 0. Okay? So you have square root of 3 cosine of 2 theta minus sine of 2 theta, all equal to 0. So what we're going to do with that is we're going to take it and divide. I'm going to set it equal, move my sign to the other side, and set it equal. What we're trying to do is we're trying to use one of your tangent equals sine over cosine, the quotient identity towards the top on the left-hand side. It says tangent of a number equals sine of a number over cosine of a number. So if we can take this and make it where it's sine over cosine, then we can figure out one more thing to simplify it down and get it that much smaller. So this gives us the square root of 3 cosine of 2 theta equals sine of 2 theta. Okay. Again, we want the sine over cosine to get our tangent. So we can divide by only the cosine. because we don't need the root 3 in there. That won't give us tangent. We only want sine over cosine. So that gives us the square root of 3 equals sine of 2 theta over cosine of 2 theta. Since the insides are exactly the same, sine over cosine equals tangent. So square root of 3 equals tangent of 2 theta. Then you can take this and turn it around like we were doing earlier on in the semester. 2 theta equals tangent inverse of the square root of 3. So in your calculator, you can get that on second tangent inverse square root of 3. No, you can't. I lied. Back to your chart. The reason why I hesitated when I looked at this, I typed in tangent inverse of the square root of 3, and it gave me a decimal. With thetas, with trig, you want exact answers if possible. There's very few occasions they'll let you get decimals. So if you put it in your calculator and it comes out to a whole number, that's fine. Sometimes it happens. If you put it in and it comes out to a decimal, then you need to go back to your chart. It's the rectangular one. So we need tangent of something equals square root of 3. So we're actually going back up a step. Tangent of something equals the square root of 3. So you're going to go to your tangent row and go over, and its tangent of 60 degrees is pi over 3. Now what you need to know is they're going to want exact, they're going to want radians. So 60 degrees is pi over 3, and you have that on your unit circle. I would go and put the radians all in here. I believe that's what they want. Nope, I lied. They want degrees. They're making it easy on you this time. So tangent of 60 degrees is the square root of 3, right? So we have 2 theta will equal 60 degrees to make tangent equal to the square root of 3. Or, yeah. It's the only way it can equal the square root of 3 is if tangent of whatever is 60 degrees. So 2 theta has to be equal to 60 degrees or it won't equal the square root of 3. Solve for theta, divide by 2. Theta equals 30. Once we get into chapter 7, that's when they're going to want everything in radians, which will have your pi's instead of in degrees. This chapter, you're just fine with using your degrees because we are doing degrees of rotation. So I apologize about that. This was a really long problem. Don't let it intimidate you. The hardest part is not getting confused with all the little things that are going on. Make sure you don't lose your x prime squares. Make sure you don't lose your y prime squares. Make sure you don't confuse your sines, your cosines as you're trying to multiply. If it helps, instead of squaring it in your head, rewrite it so you write it twice and FOIL it out. So that way you get it all done correctly. Again, the 2 papers we used today was the chart and the trig identities. So make sure you get both of those printed off. They are under handouts in your Blackboard. That is the end of 4.2. You only have 2 homework assignments. They will want you to get rid of the x prime, y prime term, just like this last example is what they're going to want you to do. So make sure you understand, take their equations. Wherever there's an x, you're going to plug in the x rotation formula. Wherever there's a y, you're going to plug in the y rotation formula. Then you're going to go FOIL, distribute, simplify, group everything together by whatever variable it has so you can factor them out. Take only the x prime, y primes, set them equal to 0. Only the inside, you don't even have to take the x prime, y prime. We have no x prime, y prime on this board. I took the inside of that set of parentheses and set it equal to 0. I don't care about the x prime, y prime. I want the number in front of it to be 0 because 0 times anything is 0. Take that equal to 0, use your identities, get it down to a degree where theta equals something. Use your chart, use your identities, and that's going to be 4.2. We'll do 4.3 when I come back on next week. Thank you.